Okay, so today we're going to start thermochemistry. The word thermo means heat. So we're really going to concentrate on specific heat problems. As we get into general chemistry 2, we'll go more into other types of thermochemistry. So this first slide is just some vocabulary. So the difference between a system and a surrounding. System would be whatever you're studying. It could be a beaker, it could be a test tube, it could be a room. So it's the whatever you're measuring the heat of, and then the surrounding would be everything outside of that. Could be your hands, could be again the room. And then when in lab we're going to make a calorimeter. A calorimeter is going to be a device that helps us measure how much heat is given off or energy is given off or absorbed during a chemical reaction or even a physical change when we change states of matter. So the first is just vocabulary. And this is continuation of vocabulary, the difference between temperature and heat. We kind of use them synonyms, but they're not really. So temperature we measure degrees of, such as in degrees Celsius, which is the unit we use in chemistry. Now when we get to gas laws, we'll be dealing with the unit of Kelvin. Here in the United States we use Fahrenheit, but other countries and science we use Celsius. So we say 20 degrees Celsius or 25 degrees Celsius. Heat, on the other hand, is a form of energy, how much energy the molecules are moving, and so the more movement we have, the more heat energy that it could possibly have. And so we're going to see the letter Q in our equation, and so that's going to be heat that we'll be solving for. So just Q, quantity of heat, I guess, is going to be heat, and it's going to be measured in the unit of joules or even a bigger unit of kilojoules. And so this slide is really important. The new system that we use, I say new, about in the 60s, they decided to standardize all energy. And so energy used to be measured in calories, and in the United States we'll still see it on our packages, etc. But the new system, everything that has any kind potential energy, kinetic energy, light energy, all forms of energy are measured in the SI system, joules, named after James Joule, who came up with that concept. It is the SI system, the international system. The older system was a calorie, and that is a lowercase calorie. And so the conversion, which I would like you to memorize, that in 1 calorie, and this is the lowercase calorie, there are 4.184 joules. That's a conversion factor you'll be using. So also need you to know that kilo always means 1,000. So if you have a kilocalorie or a kilojoule, that means you have 1,000 of those, just like a kilometer is 1,000 meters. Kilo always means 1,000 of whatever's behind it. You need to know that as well for conversion factors. So I want to point out this, and do you see the big C and the little c? So if you ever look on your packaging, our packaging system for foods, etc., they put a capital C. For instance, it says it has 100 calories. That means it actually has 100,000 calories. It's all proportional because we're allowed 2,000 big C calories, but it's kind of funny how the United States marketing system, they won't put kilocalorie on things, they'll actually just put capital C on it. Other countries, they'll put kilojoules because other countries use joules as that, and they'll put kilojoules, but we won't put kilocalories. We'll put just a capital C or little c for calories. Kind of a marketing ploy. So you're going to need to be able to convert from joules to calories to kilocalories, etc. This is the capital C here, so this is the kilocalorie. And so on your test, I actually will put kilocalorie because sometimes it's hard to see capital C or little c. So if I had 686,000 joules, an average size baked potato, how many kilocalories would that be? So we will do a dimension analysis. Not stoichiometry, just dimension analysis. joules will come down, and the conversion is to the lowercase c. The number you memorize should always go with the J. So the 4.184 is 1 calorie. That is the conversion from the joule to the older system of the calorie. And we don't want calories. We're trying to get to kilocalories, so we bring calories down and kilocalories to the top. Kilocalories, or the capital calories, are bigger, and it does take 1,000 because kilo means 1,000 of whatever you've got. We'll multiply across the top and divide by our bottom. You'll see that's 164 big C calories, or kilocalories, which is really not that bad for a baked potato. What makes a baked potato so bad is all that other lovely stuff that we like to put on the baked potato. All right, that's our example number 1.